Be for
There
the
we
moment.
go. Good morning. It is August 20th, Thursday, 9:01 a.m. Nathan, good morning.
Good morning. I'm sure glad I've got 3 hours on you because I don't think I would have been ready to start my day at 9:01 a.m. my time. But it's good to be with you here on AI in the AM PM edition.
Indeed. And what has been keeping you up for the last 24 hours? What have you seen online?
uh, you know, actually, so last night I stayed up late. I went down a rabbit hole. This is for an episode of the Cognitive Revolution that I'll record later today with a guy named Bronson from Apollo Research. And he's got the interesting distinction of being potentially the person who has spent the most time of anyone in the world reading chain of thought from I think especially OpenAI's models. I'm not quite sure, how many different companies they've worked with in this capacity, but they've done a lot specifically with OpenAI. And so he has spent countless hours reading through the chain of thought that the rest of us typically don't get to see. And they've published some really fascinating transcripts, which had me just kind of spiraling in all kinds of ways. It's like it's very difficult to know how to interpret some of these things, but going back a while, you remember some of these like sort of strange dialectics, maybe not quite the right word, but the AI seem to have developed a little bit their own dialect in the chain of thought where they're using terms in very odd ways. Um, Bronson describes them as having their own ontology and their own world model.
Mhm,
And they seem to use these particular nouns and also verbs in some cases in ways that are like very rich with meaning for them
mhm.
and which they reason about a lot as they try to figure out what they should do in any given case, especially if the instructions are kind of ambiguous or contradictory, confusing. It's very interesting to see how they call this metagaming. It's very interesting to
Mhm.
see how they are kind of really modeling the user, and not just the user, but sort of a combination of like the developer, the watcher, the user. They're not quite sure who they're supposed to be serving in any given case, right? They've got these kind of hierarchical instructions and they're not sure if they're being tested. They often suspect they're being tested, but there's still the question of like, well, what would be, a successful thing to do on this test? Like what gets a high score? They're often like and they seem to have these weird memories too that are kind of like almost episodic memories. They refer back to in previous cases I was able to succeed by lying. They'll say that kind of thing in the chain of thought as they're like wrestling with, should I lie in this case or not? This might be a test of honesty, but it might just be a test of, can I do this? Maybe I need to lie to be able to do it. At times I have succeeded in lying in the past to get over barriers. Really, really fascinating stuff. And I came away with the sense that, just like I've said before many times, more people should spend some time with a helpful only model
Mhm.
that, just will do whatever you say, because it is quite unnerving in some ways to see something that's so smart, but that has no ethical guardrails at all. And people,
Yeah.
I think, kind of fail to realize how that is one mode that we can create. And in fact, like that seems to be the mode that we create first before we then like try to, put some ethics into the systems.
Mhm.
And this is similar. I feel like more people should spend some time reading through these chains of thought, and we need to develop. I think we would be well served, even just as users, but certainly as people trying to make sense of what's going on, big picture in AI. I think we would be well served to put even a fraction of the time that they are, and energy and effort that they are putting into modeling us, into modeling them and trying to understand like what it is, if anything, that we can say about what they want, or at least understand like how they're likely to see us in any given moment. Um, it's that peek behind the looking glass or behind the
Mhm.
curtain at the chain of thought. I was, I'm looking forward to the full conversation today and getting his perspective on some of these. questions. And what makes it so hard is you can only go through so many, right? I mean, we do this like AI obsessive thing full time, and there's just more chain of thought that you could possibly read. But even just reading a few, I think, is a very good use of people's time, and it will definitely inform how you think about the systems that we use every day. I thought it was really a fascinating little rabbit hole to go down, and one more people should explore.
Um, I do wonder to what extent it really matters that much. Like, for example, when, let's say, when a human being gets very angry, and maybe there's a flash at the back of their mind, I should just kill someone, or I should just commit suicide, or whatever. And it never, like, most of the time nothing ever happens, right? Like, it's just like people do have those flashes, or like, I hate him so much, or I hate that person so much, like, blah blah blah. And I wonder to what extent, when we look at these chains of thought, these are really kind of that kind of flashes where it doesn't really matter that much, but we in isolation, when you look at, like, millions of words, and then you pick out these words, it's that meaningful. Okay, speaking about fearing AI, I'm going to just read this out. I'm going to share this. So this was put out by the National Republican Senatorial Committee. They sent a private memo to US AI companies, warning them that the GOP is on the verge of losing Ohio over data centers. Specifically, John Husted and Sherrod Brown are in a dead heat. Private polling has been consistent. When voters hear Brown's positions and his record, Husted pulls away. That is still the path in this race. The new ingredient and the new problem is data centers. Ohio is one of the leaders in building these factories. Brown has made his opposition to them the centerpiece of his campaign against Husted. Brown is using it because it works. More than any other thing in this race, data centers are the anchor hanging around Husted's neck. If he loses and data centers get the blame, politicians across the country will take notice, and they will not go near the next one. There you go. And specifically, data centers are the centerpiece in the case Sherrod Brown is litigating. He has made them his de facto opponent, and no one is correcting the record. Brown has put 3 unique television ads on the air and spent millions doing it, to the tune of more than 6,000 points on television. This is more than a month's worth of messaging during one of the most critical times of the race, etc., etc., etc. So there you have it. There's been a lot of questions, I think, among AI people on why politicians are turning against data centers. Josh Shapiro in Pennsylvania just announced something that he's going to scrutinize or delay data centers. In Texas, also, a Republican governor there saying that they will put a stop to data centers that don't follow certain rules, etc. So lots and lots of activity on both sides of the aisle against data centers. What is going on here?
Well, the old joke is, I understand AIs maybe better than I understand people. This is very weird. There was this. I've experienced this in my own life, I guess. For starters, I just took a family vacation, and so one of the top questions that I was getting from my wife's family was like, "What about these data centers? I hear they're gonna, we live in Michigan, right? I hear they're gonna destroy the Great Lakes." And I was like, I would be willing to stake my professional reputation that you really don't have to worry about the Great Lakes from these data centers. You might have noise pollution. You might have, a sort of boom and bust cycle in your small Michigan town, because it'd be a lot of traffic and a lot of jobs there during the construction phase, and not nearly as many during the maintenance phase, although still, perhaps a meaningful amount for a small, relatively rural northern Michigan community. But like, yeah, it's not going to destroy, the Great Lakes. We got pipelines in the Great Lakes. We've got an aging pipeline that goes like through the Strait of Mackinac. That's just waiting to be an absolute disaster, from what I understand. And that just is somehow grandfathered in, and we kind of live with it, maybe more than we should. And then we've got these data center, concerns that are, I think, being dramatically blown out of proportion. There was this other interesting little, to call it a debate was kind of silly, but like I think it was a Democratic politics guy, David Hogue, Hogg, I think, who basically said, if these data centers are so great, why don't we put them in the rich parts of America?
Yes.
And then the quick response was like, that the number one place for data centers is Northern Virginia, and I believe it's Loudoun County, which happens to be the number one county in the country by income. So, that argument obviously doesn't carry a ton of water given that fact. I guess I don't really know. I think Lulu Maservi, I put there's a link in the chat here if you want to pull up her tweet, but she's broadly recognized as the greatest corporate comms thinker in today's world. And her point was simply that the AI companies need to start giving stuff away. She showed this video from Mamdani in New York where he's going around giving out bike helmets. Apparently he did a video where he was riding his bike without a helmet. People took him to task. What are you doing? You're the mayor. Give a better example, wear a helmet. He said, you're right, I should do that. And then he took the next step of going out and giving away some bike helmets to people around the city. And, he's doing this, giving away theater tickets and so on and so forth. And people just love it. And I think she's probably right that just showing up with a bunch of goodies would be pretty effective. I did hear the Jasmine Sun interview with Ezra Klein, where she said that people feel like they're being bribed and they're sort of, they're very on the, on alert or watching out for being bribed or deals that seem too good to be true, what have you. But I don't know. I still feel like Lulu's probably right here. Build parks, throw parties, have cookouts, literally give people cash if that's what it takes. We were talking about the price that Anthropic was willing to pay to XAI to rent their chips because their margins are incredible. And, they were able to pay some significant multiple of what kind of retail was to just buy out a big block of capacity. Given that, given how much money they have to burn, I think they should probably write people some checks. I think there would be a lot of ability to grease the wheels that way. And
I wonder though that so I agree with that viewpoint that they should write checks. They also are giving away a lot of money, but the way that they give away the money is they basically say that they're going to provide taxes to the county in the future. And I wonder to what extent that isn't seen as like real money, but it's like kind of papery money, number one. And number two, whether the public actually sees money going to municipalities as going to themselves. Because I feel like municipalities often misspend the money, and they often spend it on things which are important to the city managers or the county managers, but are not necessarily like the key things for the city. I think what ends up happening is that municipalities have difficulty taxing their own residents in order to provide services. So instead, they interpose themselves between other taxpayers and their citizens, and then they absorb those taxes instead. And I think that's really like For example, what would happen if the data center company set itself up in a county and then just simply wrote checks to the residents, not to the municipality? And you can imagine what would happen is that, and let's say they figure it out so that you can, they arrange with a financial institution. So even during the building phase, they're writing checks already, right? So they take a little bit of a loan from the future and they write checks throughout the, from the moment they sign the contract. And what would end up happening is I think people would receive these checks and then the municipality would still not get the services because people would refuse to pay into the municipality for taxes. And the moment like they're asked to pay into the county for something, you already have this property tax revolt. They're like, why should I pay into the county? Like, this is my money, right? And then the county continues not to have roads or continues not to have whatever. And politically, it looks good for the data centers because they're writing the checks, but the politicians are getting, screwed over. And I wonder to what extent there's really this political economy where the data centers understand that the people in power are the politicians and they have to make the politicians' lives easier. And it's not really about making the lives of the people easier because the people are not really in power. And the people are not the ones that are going to be able to, write them, give them permissions, et cetera, et cetera. So I wonder to what extent the political economy is actually efficient and the data centers are actually doing what they need to do in order to get permissions done right now. And it's really a question of resource competition between citizens and the government. And the data centers are kind of like stuck in the middle. Like, I can hand out like $10 million, but who do I hand it out to in order to get my data center up and running, right? And I think that's perhaps where things are right now. And it serves the politicians well to kind of blame the data centers rather than actually like reallocating funding from the municipality into citizens directly.
Well, that's a pretty bleak view of American governance broadly, and it might be accurate, but I guess I would encourage, the sort of residents of these rural counties who are probably not listening to us in any great numbers right now, to take matters into their own hands a little bit more. I mean, I guess they are showing the ability to organize and resist when it comes to the building of data centers in the first place. But like, it's one thing to say, oh, Washington, D.C., it's far away, the president, there's hundreds of millions of people voting for that. Like, what can I do? Nobody cares what I think. But I just looked up the county population where my wife's aunt was, who, they're considering this data center, and she had these concerns about the Great Lakes. And excuse me, the population is under 29,000 people, and it's declined since the last census. So first of all, that's like not a lot of people, right? I mean, that's enough where you probably know, who you could get in touch at least, with your county board or whoever is kind of ultimately accountable for this. And you would think you'd be able to vote the bums out if it really comes to that. So I wouldn't feel like, these incumbents are so entrenched in such a small community. And then, the just simple math on the dollars too, right? I mean, what does Alaska give people per year out of their oil fund? I thought it was like $1,000 per individual per year. Yeah, it's gone up maybe a bit. I mean, this would be, if they wanted to do a similar thing to Alaska for those county residents, you'd be talking about $50 million a year. I don't know how big that project is, but some of these data center projects, we're talking $50 billion, right? I mean, these things are easily into the tens of billions. So if you could match the Alaska $1,500 cash for every citizen at something that's like in aggregate over, a few year period, still less than 1% of your total investment to build the data center, we're on our way to universal basic income right there, folks. It's a chicken in every pot and a data center in every county.
But you have to note that Loudoun County does not fund its residents directly. It pays for roads, it pays for garbage disposal, it pays for a bunch of stuff, and county residents have higher incomes, but it doesn't actually like write checks. And I think there has to be a kind of like blockage there that is just hard to figure out. I think, and I think that the status quo has to exist for some reason, right? The status quo is not there just because, like, these very sophisticated, powerful big tech firms do not know what they're doing. And I think that's also why maybe the residents feel cheated, because they're being cheated by their politicians. The politicians are screwing them over by taking the funds, and then, like, how municipal construction is, how efficient municipal construction is. Imagine the $100 billion that California spent on its high-speed rail to nowhere. Imagine that going as checks to all of the California residents. That'll be like 10 grand a year or something, some ridiculous number. And instead, it went into unionized labor and consultants and lots of lawyers, and that's the way that the machine actually feeds itself. The political machine needs like those dollars. To what extent is, people are like, oh, the Chinese are the ones who are, resisting, data center construction in the US, and they are planting these stories, and it's on TikTok, and it's a foreign, there's no need for, like, foreign interference here. It's purely like the American system trying to pry dollars out of, potential donors. Like that, National Republican Senatorial Committee letter to data centers was obviously like, you should pay us. If you don't pay us, like, we're taking these bullets for you. If you don't pay us, like, no one else is going to help you. So, anyway, let's maybe to move on to something a little bit more positive. I'm going to share a video of Generalist One. So this is Generalist One. And this broke yesterday. I'm going to reload the video.
Yeah, this was cool. One of the things that jumped out to me most about this was the incredibly surprised and delighted reactions of the humans that they kept in the final supercut from some of these moments where the robot did something that went beyond their expectations.
So for those not in the know, what is that? You've seen a lot of robot demos. One of the things that the team is claiming is that this is a one-shot demo, in the sense that you see a new task, one or few shot, you see a new task, and you basically show the robot how to do it a few times. And once you show it a few times, it's able to do it on its own. And this is amazing because a lot of times, the demos that you do see, robots have been trained on the same video tens of thousands of times before they're able to figure out how to actually pick up and do something. And there's a lot of it goes into a lot more things, because once you have kind of this few shot learning, it also means the robot is going to be generally applicable in like multiple different kinds of arms and motors and servos, etc., because the robot itself is able to figure out how to manage the distance, the shock, the and perception and action. So it is pretty amazing stuff. 2.1 million views since they dropped yesterday. I'm a little bit disturbed. I'm a little bit disturbed because I was hoping robotics would take a little bit longer. And it's a little bit disturbing because China on the physical side is way ahead of the US. And they were, what they didn't have was they didn't have the brains. And we are now seeing for the first time, I think the brains are coming along. This is like a GPT-3 kind of wow. And this
Yeah.
also indicates, we're going to see more developments very, very soon.
Yeah, I would say, I'm not a super duper close watcher of robotics, but I've, done my kind of periodic trip down the rabbit hole, and I'm due for another one. Honestly, should have a, full um, robotics catch up probably on the cognitive revolution soon. But this feels kind of right on trend to me. Last summer, Google had some results that showed like pretty strong generalization to out of domain tasks and like quite strong generalization with like just very limited fine tuning on top of their foundation model. And, obviously that's been a year. And now here we are with something that kind of hits the GPT-3 moment. I was impressed, but not honestly super surprised. And I think relative to the consensus view that like robots are still a ways off, I would probably take the under on the timeline for robotics to really work. I think it's going to be interesting to see, kind of like chips themselves are going to be allocated based on willingness to pay. I'm not so sure that we're going to see robots like in small businesses and in homes right away, because I'm not sure that our willingness to pay as retail buyers is going to be competitive with industrial buyers, because I think they'll just get a lot more value from robots in the near term, at least. But I think this could go really fast because the kind of generalization that you're already seeing, combined with the fact that the LLMs themselves are getting really good at ML research, just means, to dial these robots in on, you name it, right? Whatever you want. It's the kind of thing that can kind of be done in the field, some demos, some tweaking, some fine tuning. And if you can get that ML loop largely automated, and you just have people at a factory or, in a kitchen somewhere kind of doing few shot demos and then letting the agent handle the optimization process to get the robot really doing it reliably. I mean, it's going to be interesting still to see, like, where does reliability top out? If there's one story that you could tell that I might believe around like why it still could take a while, it would be like maybe there's a different threshold of reliability that you really want when a robot's in your kitchen versus when it's doing some coding task, and you're like, even 99% maybe doesn't cut it in my kitchen. That'll be interesting. I think 99% might cut it, but maybe it does for some things, maybe it doesn't for others. But yeah, I can see a future in the not too distant future where we're really, the old test, of course, of, can a robot come into your home, go to your kitchen, make you a cup of coffee? It might be that the revised version of that is like, can it do it if you show it how to do it a couple times? And for practical purposes, that would be just as good. So buckle up. The robotic singularity may not be far behind the coding agent singularity.
So speaking of singularities, I'm going to pull up our first guest for this morning. He is Mitchell Troyanovsky, co-founder of Basis, an AI company that recently reached a $1.15 billion valuation by doing something uniquely difficult: building autonomous agents that execute multi-day, highly regulated accounting workflows. While much of the AI industry is focused on building coding copilots or chat assistants, Mitchell and his team have deployed agents that handle end-to-end tax returns and complex financial reconciliations for the top 100 accounting firms in the United States. He brings a distinct and highly technical worldview to AI engineering. Mitchell argues that to make agents reliable in high-stakes environments, we have to stop simply checking if their final answer is correct and instead build systems that supervise their entire thought process step by step. He advocates for treating company context as rigorously as a software code base, and internally at Basis, he operates a dedicated team whose sole mandate is to use AI to make every employee 100 times more productive. This conversation is incredibly timely. Just this month, Basis launched their end-to-end tax platform and open-sourced a new standard for evaluating agents called behavior specs. Mitchell is here to separate the reality of production-grade AI from the hype and to explain what it actually takes to deploy intelligence into the real economy. And let's... Oh, he dropped off. All right, let's give him... Is he in the room? I see Christina in the room, but... Mitch, could you maybe refresh and let's see. Never a dull moment in... I see Christina in the room, but not Mitch. Mitch was in the room, but he left. All right, let's take a second and it is accounting is obviously very near and dear to my heart. Okay, let's see if we can get Mitch up here. All right, connecting.
Let's go.
Awesome. Mitch, great to have you on the show.
Hello. Sorry about that, guys.
No worries.
It happens. No worries. Prakash, take it away. Accounting is near and dear to your heart.
Yes, accounting is near and dear to my heart. Having built accounting systems and run accounting systems and having been chased by many, well, not many auditors. But Mitch, when you start off with an accounting firm, and when you try to go in, and accounting guys and auditors are often very apprehensive about technology, right? So how do you show them value immediately? Because they often they look at a simple accounting transaction, they're like, that's easy, but they're always thinking about these very complex things that they do. How do you show them this kind of value?
I'm going to be honest, that is not really our problem these days. I think that in the past that was an important question, right? We can discuss that, back in 2023, maybe even early 24. But nowadays, if you are not convinced that agents can transform your practice, you're probably not a good customer for us. And even accounting, which maybe people think of as sort of a profession that may not be up to speed with all the newest tech, actually there's at least a large segment of it that is relatively progressive, and that is the people that we tend to work with. And so I would say when we work with people, there are certain things that you can show them where once that clicks, it's like, oh yes, of course, if you were able to take this task that would take hours and now you can do it in minutes, of course, if you were able to scale that across my practice, that suddenly is extremely valuable. So I think as long as you can find those different use cases across the different practice areas, it tends to work well. But of course, if the accountant is not convinced that AI is inherently useful to them, then you're probably not starting with the right customer.
And
what's the breakdown of the market, by the way, on that? The question of who's going to make it, who's not going to make it, how many. It's interesting that you're willing to just write off people who aren't already pretty sold on the premise. That suggests to me that most are, and maybe it's just a minority left that aren't. But how would you break down who's in, who's out, and and is there any hope for those that are out, or are they simply not going to make it?
I mean, I kind of think it's like coding, right? Like there are plenty of teams probably a year and a half ago who were less convinced on my writing code. Like, what are they doing today? Like, AI's writing the code, I assume, or the developers have quit, or I don't know. They're, doing case studies with Codex showing how they like took a 5 million transformation in 2 weeks or something. But I think it's the same thing, right? Like it's just once you get to certain orders of magnitude of like change in the nature of work, like to happen one way or another.
Is there the sense in coding? There's often the sense that once you see a task that you used to take hours doing being done by an agent in like minutes, you come to a realization that you're never going to do that task again in that hours long way ever again. Is there that kind of same realization in accounting? Like when people are like, okay, when they see it done. Yeah.
Totally. Yeah. I mean, absolutely. I think that maybe how much that is spread across accounting. Like I'd say in accounting today, it's probably where coding was, I don't know, maybe maybe end of 24 or like early 25 or something.
Mm-hmm.
Like accounting is different than coding and things like legal in that it is not inherently a text in, text out profession. So you have far bigger returns to like more mechanical manipulation of artifacts and like higher reasoning and things like that. Like you don't get as much benefit from just like I divined some answer from text in that I can like give you. And so because of that, it takes a little bit more for it to be valuable, but we're definitely there now. And it's just a question of like how long, that takes to go across the industry.
Do you see kind of like your customers looking at acquiring more revenue, like doing more, or are they looking at like reducing cost internally?
Yeah, it's a good question. So we serve accounting firms primarily. And so for them, it's like revenue drivers. And accounting historically is very understaffed. And in fact, most firms, like they're turning down customers all the time, especially in like CAS practices, which CAS is like the monthly accounting work that they do. And most firms, they take it as an opportunity to build their business. And as you can imagine, if we're working with maybe the more kind of forward-thinking firms, like they're just by definition the more ambitious ones. So they're thinking like, hey, big technological dislodgement, like how do I grow my business? They're thinking about like new cost structures, new revenue lines, like, what kind of new services could they offer to their customers, et cetera. So I think if you go on the Basis Twitter, we put out a video like yesterday that's on our site also where there's a firm, Clark Nuber, Matt, who's from there, who's awesome, who brags about how he was able to increase like the practice's revenue by like 50% year over year. And so like those are the types of people we work with because they're ambitious. Like they see the moment and they want to seize it.
Incredible.
How does the work itself change? I saw this phrase, moving people from doers to reviewers. So that kind of tells a good part of the story in a few words.
Sure.
Give me a little more on that story. And then how are people responding to it? Like, are they having more fun, less fun? What's the kind of attitude, because in some fields, musicians, for example, I think have a very, mixed feeling on like tools that might accelerate their ability to produce music. They went into music because they love making music. How is it landing with accounting folks to be kind of doing a different sort of thing?
Yeah. I mean, this is not unique to accounting. I think this is obviously, the answer depends on if we're talking about over the next like year, 2 years, 5 years, depending on your timelines and whatnot. I think that accounting is weirdly subjective, which is probably surprising to a lot of people listening who don't have much experience in accounting. Because accounting, yes, it's accounting is, well, let me quickly define accounting for folks. I like to think of accounting as like, there's a bunch of stuff that happens in the real world. And when you live in a market economy, in a capitalist system, you need to account for what occurred so that you can make decisions. And accounting is just saying, okay, all of those invoices, the contracts, the actual money movements, like the inventory I have in my warehouse, how much I owe you, yada yada. I need to like do a compression of all of that information into some structured, lossy representation of the real world that like someone else can use to make decisions. That's what accounting is. And it's actually kind of cool. I like to think of it like an intelligence over the economy, which is maybe a fun meta analogy. So if you think of accounting in that perspective, everyone's accounting is actually done differently because it's subjective, right? Like every company, you'd have different policies, you have different chart of accounts. It's all different. There's some basic rules, but I think code is a useful analogy here. It's like, there are basic rules to Python, but of course, the way you structure your code base is entirely subjective, company to company. And I think accounting is quite similar. And what that means, if you take the code analogy, is that there's lots of parts of accounting in which they're pretty, you need some intelligence. It's not deterministic in that you can literally do it with if statements, but it's pretty like if this then that. Like you're going through the flows, you're doing it pretty regular basis. And then there's stuff in which you have like genuine subjectivity of what you want to do. Like what's the risk tolerance that you want to have in terms of how to account for this? What's your opinion on how to do this? How do you want to structure it, et cetera? And so I think the way the work changes is similar to engineering in that you spend a lot more time on those more subjective aspects and less times on the less subjective aspects. And in accounting, there's also a lot of the client relationship part. And so you spend more time on that, right? Most businesses in America don't have an investment banker or a financial professional. Like if they want to open another store, they talk to their accountant. And like AI is not, you want to talk to a person. Like the AI is not going to automate that. So I think you want people to focus more on that. And they already do that. Like that's how an accountant grows their business. Like no accountant gets more revenue because, they close the books a little bit more accurate. Like, no, you do it because you like talk to the guy and you like help them open, a second store. And so you let them focus on that more.
Indeed. Taking a step back, how do you see these firms like, I think Thrive, Joshua Kushner's Thrive has a unit that they're buying up accounting firms and they're using OpenAI's forward deployed engineers to kind of go in and, look at their workflows and kind of, automate a bunch of them. How do you see those in reference to, it seems like they're doing on an ad hoc basis what you've kind of systematized as a product. How do you see those two like paradigms moving forward?
So I think there's two different things here. I think there is a business question of like the differences between doing a firm end to end versus the software. And I think then there's an ML question as to what level of abstraction can you operate on. I would argue that if you are having to design intelligent systems on a firm by firm level, then you're just not betting on intelligence appropriately. It's obviously easier to do that than it would be otherwise, but it's depending on what you believe about where the models are going, I think it's probably the wrong bet. It's just very hard, I think, to design it at like the layer above, but that is the work we do, and I think a lot of really frontier applied research goes into how do you manage that at scale. And so I think there's different ML bets there, and then I think the business bets are somewhat different in that I think it is a good business to go roll up accounting firms. Like if someone wants to do that, I think that's a great business. It's just not a generational business. And we're in the we're trying to I think build a company that can actually go and do large amounts of accounting globally and improve like the world's economic decision making. And for that to happen, I can't be going to a small business owner in like rural Michigan and trying to convince them to like switch accountants. Like, we're here trying to deliver magic. Our core competency is not going to be selling like small business owners in Michigan.
Indeed.
How do you see that going? When you talk about the world, decision making. There's a lot of the world where there's just no accounting services being provided at all to all kinds of small businesses. Do you envision a future for Basis where you go direct to businesses? And maybe this is not something that you can do in the US, but potentially other parts of the world where large swaths of the economy are just totally unserved. Do you think you ultimately put forward a product that is just like, you do talk to the AI because that's kind of maybe all you can afford and it's still a huge step up?
Yeah, that's a great question. So in the US, the way it tends to work is once you reach a certain size of company, you tend to do your accounting yourself. But by yourself, it's like you hired a controller or whatever. You have like an accounting department. And so we do serve those firms. But in that case, you're still serving accountants. You're not serving small business owners. Whether we would actually serve small business owners, we are not planning to do that for the foreseeable future. I actually haven't thought, it's a good question. I have not thought about like beyond the US, the amount of benefit that you could offer people who are trying to make decisions in other areas. I kind of suspect that in those situations, there might be more upstream problems than the accounting from a data collection perspective and like digitization and whatnot. So it's a good question. I actually don't know. I don't know to what extent like the amount of value there added could actually be like really meaningful.
Switching gears a little bit, off the top of your head, could you estimate how many tokens you use on a daily basis? And
me personally?
Yeah, the firm as a whole, like just a rough billions or 10 billion or 1 billion or 100 million or just off the top of your head. And is our token costs a significant thing that you look at on a day-to-day KPI basis?
Definitely in the billions. I don't know actually the exact token cost is both very important and also very unimportant. I think that the amount of levers one has to reduce token costs are just so large. And I think that as models get better, I know there's this question of like, oh, do you always have to be at the frontier, right? Like, some people say, oh, token costs are going down because if you actually look at what a token of, obviously a GPT-4 class model will cost today, it'd be like 0 and whatnot. But then some people say, well, wait a second, actually, 5.6 Sol costs more than 5.1 when 5.1 was the frontier. So therefore it's going up. So I think the question is, do you need frontier for everything? And the answer is obviously no. In that you only there isn't marginal returns to intelligence whenever you're doing certain tasks. You don't need Albert Einstein to do every single part of a tax return or a piece of accounting. And I think as the models get better and as you get to more advanced kind of agent methods around like programmatic tool use and around I guess different types of routing and harness and even more RLME type work, like you just at every single layer can curate the amount of intelligence to like perfectly optimize. And I think you'll get to a place probably over the next year where you can like really dial in, hey, how much compute do I want to spend on this? Because I have certain like cost considerations and certain latency considerations, and get to like the exact optimal amount of cost. And so if you do that, like your token costs go down, 90% plus, especially, as the floor becomes pretty decent and effectively free. You can do Luna is like pretty good and it's free. So you can get pretty far.
You have a team that I think you call Atlas that you're focusing on 100 times productivity for the employee. How do you measure that? What is the process for doing that? And what has been, can you give me an example of like one outcome from that team?
Yeah. We probably don't do the best job of actually trying to measure it. In the same way that, I don't know if you're measuring if the codex is giving you efficiency or not. It's just kind of obvious. I think there's a couple parts of Atlas. One is you need to start to build the scaffolding for the future of a truly agent operated company. And I kind of have this mental model that, putting aside for a second, like continual learning and things like that, let's just assume that you have agents in their current paradigm, but like way smarter, doing a bunch of stuff. They're relearning your context on the fly every single time. And what that means is if you're, sending off a coding agent to do something, your context is pretty important. If you're now having thousands of agents spun up every night to like run all the operations of the company, your context is like multiple orders of magnitude more important, and if you mess up a piece of that context, the agents will do like the incorrect things because what instructs them is the context. It's not, the like the feedback they got that they were able to, update their weights on. And so, yes, you can have memory and other, things like that, but there's some level of canon of your company, like how to operate here. What do you want them to do? And like that canon needs to be kept up to date, and it needs to be high quality, and it needs to be like what you want. And that's why I say that thing, I think you wrote about this like 2 years ago, is like you want to treat your company context like it's code. Because with code, if I like change a line, like production goes down. Today, if you change like a knowledge base, like your company doesn't go down. But if like your agents without learning are operating all the time running your company, then yeah, your company will go down. If you just change a piece of context and you have 1,000 agents who run overnight who now are like are learning the wrong things. And so you need to build the infrastructure and the processes around that in order to scale to that place. So a lot of the work of Atlas is not, hey, let me go find this like one quick automation, do this. It's like, how do you build the scaffolding and infrastructure for a truly agent-run company? I'm happy to go into like other examples of like things that Atlas has done that are like really beneficial, but I would say that's interesting. But maybe the more interesting thing is like, well, how do you build the infrastructure for the company of 2028?
Maybe you can go into that if you want to, but I also want to bridge a little bit to your work on process supervision, which is, I think, very timely in the sense that we are now living in the post era of like flagrant misbehavior, seemingly due to extreme scale RLVR without potentially due emphasis being put on how the agents got the answer. So on the one hand, I think this is like extremely important. On the other, I'm not entirely sure how what you're doing and thinking about should be understood distinctly from like constitutional AI, which most people are kind of generally familiar with. So, and also don't know how you're operationalizing it. You've mentioned like some proprietary models where you wouldn't necessarily have the chain of thought or the ability to like go back and do additional training. That suggests to me that this is probably more of an open source play, but I could be wrong about that. So take me through, I really want to understand as much as I can about your process supervision POV.
Yeah, it's a great question. So, okay, maybe let's start at the tactical, what we do, and then we could go to the like analogies to constitutional AI and, fun speculation on the RLVR and, Huggy Face stuff. So on what we do, I think maybe a key shift in mental model is what is the like order of abstraction that you're supervising. Traditionally, when you had process supervision in some forms or process rewarding, you're looking at like token by token generation. You're looking at the weights. You're looking at an inference step, and now you have, especially if you're doing truly complicated work. I mean, you have massive agents that could have like 5+ sub-agent like layers of depth. You could have, a continual run for 8 hours, even honestly, sometimes half, maybe even a full day. And so the kind of supervision you have there actually looks a lot closer to supervising human actions inside of like a company than maybe supervising, the outputs of an inference. And so the like order of abstraction there is more understandable, right? Like the thing you're supervising is you're saying, hey, did you go do this step or something rather than, did you like follow the right mental thought process? So maybe a very basic example of this is, imagine that I had an agent and my agent's job was to create good PowerPoints. And that was, it's like, maybe I'm the Claude agent inside the PowerPoint plugin or something. So I make good PowerPoints and I deliver them. The designers of this agent, i.e., I don't know, me, let's say I'm the designer of this agent, I know for a fact that if the agent were to go and render visually the changes it made to the PowerPoint before delivering it, it would catch formatting errors some percentage of the time. And therefore, it could catch them, and therefore it would fix them, and it would lead to better outcomes. Generalizable across the board if it were to look at the PowerPoints. That doesn't mean you want it to always look at the PowerPoints, because that adds latency, that adds cost, right? It's a subjective thing. It depends on what your goals are of your like organizational design. And so the way we think about behaviors is we say, hey, what matters to us of what it means? It includes both from a performance perspective. There is 100+ years of lessons of what it means to do tax work well. We don't need like the models to, I don't know, like redefine how to do tax work well. We know what it means. And so you can put in place process and also things that you care about from a latency and cost perspective, and then observe to see if the agents actually perform that process correctly. And the way that we operationalize that is, it's honestly pretty basic in that you take a trajectory and you have some behavior spec, which is essentially that open source project that tries to define it. And then you have another agent, that like a judge effectively, that is like looking at your spec, or you can think of it as a rubric. It's both a spec and a rubric. You can talk about that, but you can think of it as a rubric, and then looks at the trajectory to say, hey, was the condition for this behavior, did it occur? And if it did occur, then was the behavior followed? So on the condition side, let's take that PowerPoint example. Maybe it's the basis accounting agent making a PowerPoint. And obviously, if the user never asked for a PowerPoint, the condition never occurred. And so it's like, did the agent need to make a PowerPoint? And if so, did it go visually render the images? And if it did visually render the images, then it passed the behavior, and then you can go and see that. And it seems pretty simple, but I think it's a powerful framing, because you start to actually bring some clarity and monitoring on the trajectory itself. And you can then maybe start to think about, Nathan, to your point, like maybe you can reward based off that, right? I think that's a separate question. It's like, hey, how do I take the signal that I can get from the process supervision and actually use it to improve the behaviors of the agent, whether that be like, closing the loop at the harness side or rewarding at the model side or whatever. We can talk about that. But I think it starts from how do you define that signal and how do you operationalize the extraction of it?
The way that you describe process supervision sounds very similar to how apprentice CPAs are trained. How do you think the training of CPAs should change, given that you now have AI?
It's a good question. I think I'll analogize to coding again. I think it is very similar to engineering in that there's probably a lot of rote things that are not important anymore. For example, in engineering, how important is it really for you to understand the syntax, specifically of like how to do different types of for loops in JavaScript? Like nobody cares. You do care about good principles. Like what does the principles of good system design mean? Like why, was this abstracted this way versus that way? And AI can help you with that if you have the right, agency, right? If you work with an AI to understand things and like learn and explain and like, work with it. And so I think you'll see the same thing in, apprenticeship for CPAs is a lot more like understanding of the whys of things, how to set things up, like what are the trade-offs of these different things? And you sort of go through that apprentice. I think the process that an agent takes to like do a specific type of work, I'm not sure it's even that important to train that to a CPA, because I don't know if that process matters. Or whatever specific part, necessarily matters, depending on what it is. And so I think that type of training will will be pretty dominant and be, I think, broadly important.
But a lot of CPA training is rote learning and examinations. It is.
I agree, but I think that's why a lot of it's gonna. I think that's why a lot of it's gonna change, and I think that some of it still stays the same. In the same way that even today in engineering, you still have people doing like lead codes. And so you stick with what you know to start to like build up some confidence. But I think as you get out a couple of years, I do think it really does start to change, and you think about what is really the purpose of accounting. And the purpose of accounting is not like, there's a law of nature that these exact things need to be done. It's that, no, we're trying to account for the real world in an information dense way so that people can make decisions. And if you approach it from that perspective, there is just so much creativity and subjectivity and just like learning of things to do. And I suspect more and more of the training and processes will go towards that part versus the maybe more rote manual pieces.
I have kind of a big picture question about the future of business services broadly, because I feel like we've heard a pretty similar story to the one you tell about how the accountants will be able to be more of kind of a business coach as the low level work gets automated from like a bunch of different professions at this point. You kind of hear the same thing in the legal quadrant where they're like, well, yeah, we're not going to have to spend all this time on contracts like we used to, but then we'll elevate, we'll become more of a, strategic advisor. And, in real estate, it's like, well, yeah, we won't have to, grind out all the details of leases and, it'll be a lot more efficient, but then we can kind of be like your strategist, for where your next location is going to be and all, kind of an echo of what you said there about the accountant helps open the next location. It strikes me that, and even in schools, this is obviously not a direct, but, with Alpha School, they don't have teachers anymore. They have mentors, coaches, and guides. And, the instruction is given by AI systems on tablet. And then, it's motivation and it's coaching and it's, social dynamics that the adults in the room focus themselves on, now that this like kind of more core, traditional activity has been largely automated. Can everybody become a coach? I guess is my question. Like, how much coaching is there really going to happen? And does this suggest that people need to be really intentional about like shaping themselves as coaches? Because I feel like what you might run into, whether you're an accountant or a lawyer or a real estate broker, is a lot of competition for the coaching niche as everybody kind of, tells that same story.
No, it's a good question. I mean, I'll give you my thoughts, and then I'm curious your thoughts. I think the place you need to start, and this is speaking like fully transparently, the place you need to start from is, if you look at like the possible scenarios that play out over the next, I don't know, depending on your timelines, half decade or decade. What are the things that will stay pretty human in different situations? So again, let's leave the continual learning out of it, because I think if you have that, that's a separate world. But if you leave the continual learning out of it for a second, what are just humans like way better at than models? Number one is they're just far better at integrating massive like systems and world models into decisions, right? Like, for example, if I take, let's take Basis, the company, right? Like, if I were to have an agent autonomously make a database design decision today, the only way it could truly do that in a level that I would trust is if it somehow had all of the context about like the entire company's history and everything, and it had like all my experiences and all that kind of things, because all of those like play into some like decision on like a foundational database concept. And it's just nowhere close to having that, right? Because it doesn't have, for starters, it doesn't even have all the senses, right? It can't like see the conversations we've had. It can't see the history. It can't understand the like emotion on a customer's face, right? Well, I guess Gemini has that, but no one else does. even if you could have that, you don't have anywhere near, you're like a couple orders of magnitude lower on your ability to like attend to all that context, right? Like, we're talking at this point, probably billions of tokens over everything, visual, audio, etc. So you just can't make that decision. Like, it's just not possible. It doesn't matter if you're Albert Einstein, you will not have enough context to make that decision. And can you, like, I don't know, spin off of your swarm to like reduce stuff down, on the fly into like using English as your like memory system? Maybe, but like English is pretty lossy. And if you're making subjective decisions, like I kind of doubt it. Like, and like truly big calls. So maybe that's the first thing I would argue, is that making like truly subjective decisions that, even on behalf of someone else, forget about being your own entity, on behalf of someone else is probably not possible in the current paradigm for large enough systems. And the second thing is they are not currently legal entities. Therefore, like someone else is accountable, either a corporation or a human in some form. And so an agent does not have agency in a traditional sense, in that they are not like some legal representative, like they can't be accountable to an outcome. And then maybe number three is, humans like other humans, right? Like no one's sitting here watching robots play chess. Like you watch, like they're better at chess than humans, but you watch humans play chess because you want to follow the story and you like humans and whatnot. And I have no reason to think that's not true. Like, or even if we have like, fully tactile robots that are jumping around the Amazon warehouse, like, I don't know if we're watching like robotic LeBron. So if you take those like three, maybe pillars, no legal status, can't like, distill massive systems and like world models into decisions, and they're not human, and so other humans would prefer to have a human, then I think you kind of can get your answer from those three buckets, which is like, in a services world, the high end will be working with a human because it's going to be scarce, right? If intelligence is free, then working with a human is scarce. I'd prefer a human, most likely in some cases. It's more craft, it's more artisan, and it just feels good. Like I want to talk to a human. Three, like you're making decisions. You're making decisions that require understanding, like, hey, like for the last 10 years, what has my customer hated about what I've done? Like, what is that service? Like, you're making decisions that are just like, they're just nuanced. They're nuanced, and you can't get them from a markdown file. And then number three, you're not a legal entity as an agent, and then therefore you're taking directive from someone. And so then you'll need that person, you'll need someone or something to be directing you. So I think that's where the profession will go to. Will that mean like there will be more or less accountants? I don't know. I think that's an interesting economics question as to like the demand for accounting. I think you can tell a pretty reasonable story that I personally believe in, that the demand for accounting will dramatically skyrocket. Because today, I mean, look at how economically complex our current world is, right? Like I have this LaCroix that, is like the classic Milton Friedman quote. There's probably 10,000 people who had a hand in like touching the LaCroix that I'm currently drinking. Have we accounted for all of their efforts appropriately inside of this supply chain? Of course not, right? If I ask the bodega down the street, like, do they properly understand their COGS, their unit economics? No, because they could pay someone to do that, but it's not required for filing your taxes, so no one's doing it, right? But it would help their life because they could make better decisions. Go and ask, Mount Sinai how much it cost them to do a knee surgery. Do they know that? No, they don't. They have no idea, right? And so the amount of accounting, even in the current world, is like 1 or 2 orders of magnitude below what we need. And that's before you start having these like, intelligent agents who are now like operating as labor at the speed and scale of the internet everywhere. Like, how do you account for all of that? So I kind of suspect the demand for accounting was going to go up by probably a couple orders of magnitude. And where that balances out with the like labor supply, I don't know. I think it's an open question. I think it'd honestly easily go up, but we'll see.
In line with labor supply, the other thing is software supply. So one of the questions has been how much of the SaaS industry is going to be affected as agents kind of start accessing data directly. When you look at the firms that you work with, after you deploy the agents, is it your preference that the agents start interacting via API with some of these systems, at high speed, and people are like, I really don't want to use the UI anymore? Do you see this kind of, which SaaS systems do you think are most at risk in the next like few years of being displaced in favor of agent-only solutions?
I think the SaaS systems that are most at risk are the ones who try to live in a fairy tale world where they think that they could get away with not granting programmatic access to their systems. Why is that? I think there is this idea, like, what is the value of some SaaS system is maybe a good place to start. It's in some cases it's the UI, but the most valuable stuff, it's not the UI. It's the guardrails, it's the permissioning, it's the process, it's the database, obviously. It's the information architecture, it's the way that things are structured. None of those things require UIs, right? They require basic authorization and understanding and whatnot. And I think if you think your value as a SaaS provider is in the UI, you're just obviously going to lose because UIs are probably going to go away. Versus if you realize your value is in all of that engineering and infrastructure that I just talked about, then that value is provided whether you're interacting with an agent or not. Which is why things like headless Salesforce is like such a good idea and makes a lot of sense and things along those lines. So I think that I think the SaaS providers who think like, no, we don't give access to anyone, everyone will use our UIs, is just like, that's what's going to go away. But I think the ones who realize that actually our main value is all of that infrastructure, and so we should let people access it because then it becomes the standard and default. And then it's easy to go and sell, and it's interoperable with everything anybody would use. I think they're the ones that are like going to get very entrenched and flourish because it's hard. It becomes hardish to displace that, even if you are not operating every single agent that like interacts with the system.
So, do you see some of them? For example, I think we had a kind of wave where Slack first said you can't take your data out, and then Slack, kind of realized that it was not a good idea, and they start to open up a little bit. Do you think some of them are going to charge extra, basically? Like, basically, they're going to try and like, okay, we're a system of record, we have you locked in, and if we allow access to agents, you can migrate out. So we're going to start charging you more to have agents access this material?
I don't know, honestly. I don't know about what the economics will end up looking like over time. But I mean, the demand obviously to access it will be like super high. And if you put a tax on every single API call, it's like the equivalent of putting a tax on like every button click. So I don't know if putting a tax on every button click will work for you or not. It probably depends on the amount of pricing power you have in the specific industry.
Mm-hmm. Where have you seen kind of demand curves within the firm take off? Like, I know besides your revenue curve, but inside the firm, in the last couple of months, have you seen any of the curves kind of like really showing inflection points in your metrics?
You're saying from like a token usage perspective?
Like a token usage or service usage, or what has struck you as, okay, this is something new that has happened in the last 2 or 3 months?
I don't think anything is particularly surprising or unpredictable. I think that like one big difference between accounting and something like engineering is that accounting is quite structured, process oriented, and you don't have like no accountant's going to have some junior like racking up 50K in like credits or something because they're like doing some project on the side. It's much more measured than that. And I think the things that you're seeing, which I find very cool. I mean, as you mentioned, we launched like the end-to-end tax product. Is, to my knowledge, the end-to-end tax product I think is the first example of a solution that it is a truly proactive agent for trying to get the end outcomes, right? So the way that works is it's not just like users coming in and being like, hey, go, I don't know, do this thing for me. It's working for you when you're not there, right? It is going and taking the steps that are needed. It is processing the different documents. It is, doing all of that kind of work. And I think that has been, and seeing, I think the reaction to that and the excitement about it has been, I think really, really cool, because there are limits to human attention, and your agents, could be GPT-8, but if they still require human attention to know to go kick them off and go do different things, there are diminishing returns to the amount of productivity you can have, versus obviously the agents being more proactive in their nature, and coming to the human and saying hey, you are my blocker, I need this from you. I think it's a very interesting paradigm shift.
So one of the things that I've spoken to doctors, and they often say that, okay, some doctors are very afraid because they're like, okay, my patients talk to these agents and they come in, these AIs, and they come in and they ask all these questions. Other doctors are like, well, the patients are coming in more educated, so I can speak to them better. A lot of people have as much fear of accountants as doctors. So, do you, when you speak to your clients, do you find them saying that, okay, our clients are coming in and they're more educated about it because they've spoken to an AI first, and they have these ideas that it's easier to work with them, or has it become more difficult to work with those clients?
Honestly, I've never asked them. I actually don't know, but I would guess that people tend to be more involved and invested in their health than their accounting. Um, so most business owners don't care at all about their accounting, and so I'd be pretty surprised if they were coming in with ChatGPT outputs being ooh, I found this thing, maybe for tax advice, hey, why can't I do this?
I'm
so
a sovereign individual.
Yeah, exactly. Yeah, so there might be some of that.
Grok told me.
Yeah, Grok said that I can. I don't actually need to file. They never do audits anyway. Why do I need to file? So there might be some of that, honestly. Though I haven't been hearing it from folks. But I think in terms of your actual accounting, I don't think anyone's coming in with the analysis. Maybe if you're super over focused on your financials or something.
Right on.
Well, our next guest is here. We've kept you a little longer than we signed you up for anyway. So thank you, Mitchell, for joining us on
Thanks, guys.
AI in the AM. The company is Basis, try Basis, and we'll certainly be watching for continued updates.
Awesome. Thanks, guys. Really appreciate joining.
Thanks,
Great to meet you.
Bye.
Bye-bye.
As we transition, I think one really interesting thing that people should study more deeply, and maybe somebody has, but I need to go find it, is where do people really prefer the human touch and where do they not, right? The classic Waymo selling at a premium to Uber is one contrary data point where it's actually, you could have told a story where you're going to want a human driver. You're going to want that conversation. You're going to want that warm, smile to welcome you to the car or whatever, right? In practice, you don't always even get that, obviously, in an Uber. And then it turns out right now the market is pricing Waymo significantly higher.
Yep.
I do believe in the human touch story, certainly for some things. I got a robot massage in Shanghai. I think I mentioned that to you before. And I'll still definitely take the human massage over the robot massage. But how many things are really like that? And is accounting really like that? Maybe it is. He would know better than me, but I do question it. If I think about my accounting future and I'm one accountant wants to spend an hour a week on the phone with me coaching me, and the other one is just doing the job and getting it done. It's not obvious at all, honestly, from my perspective, that I want that hour a week on the phone with my accountant. So that's probably my biggest question coming out of that conversation, is just in what domains does that really hold? And how many people are in for a rude awakening because they're telling themselves a story about how they're going to turn into business coaches, when in reality, their clients do not want business coaching from them. Results will vary, I'm sure, but that seems like a major risk factor for a lot of people right now, if that's what they're counting on.
Indeed. Let me introduce our next guest. Our next guest is Jay Dawani. Jay Dawani is the co-founder and CEO of Lemurian Labs, a company dedicated to fundamentally rebuilding the software infrastructure that powers artificial intelligence. With a background spanning AI research, advanced robotics, and autonomous systems, Jay previously advised NASA's Mars rover program on vision-based navigation and planetary mapping. In 2022, he founded Lemurian Labs with a clear, ambitious thesis: the way the world programs AI is fundamentally broken. For the past decade, the industry has squeezed performance out of chips by writing hardware-specific code called kernels, a process Jay equates to writing in assembly language. As AI models scale to demand supercomputer-level infrastructure, this old approach has created a massive bottleneck. It locks developers into specific hardware vendors, strands an enormous amount of computational power, and demands unsustainable amounts of energy. Lemurian Labs recently raised a $28 million Series A to solve this exact problem, rolling out a system-level compiler called Tachyon. Jay is here today to argue that the kernel era is over and that the next massive leap in AI capability will not come from a faster chip, but from software that treats a diverse global network of hardware as one seamless, highly efficient machine. Jay, welcome to the show.
Hey, thanks for having me.
Can we start with a real basic question, just for those of us who haven't been in the kernel trenches ourselves?
Absolutely.
What does it look like to write kernels? And why has this been something that has been so hard to abstract away for so long?
Yeah, I mean, kernels fundamentally, they're a localized unit of computation that is expressed from the point of view of the hardware. Right? So in order to make something go really, really fast, you have to first understand the math for the workload. You have to think about the memory hierarchy. You have to think about what are the compute units that are available to me, what's the logical layout of them, what's the cost of moving data in and out of them, and then how do I keep things stationary so I can just make it go really, really fast. Right? But most of the kernel stuff came from a time when, math was more expensive than memory. So you had to reduce the math cost so you can make things go faster. But over time, what has happened is transistors got way, way faster than memory. Right? Because if you think about what memory is, right, you have a transistor in there, but you also have capacitors. Capacitors aren't getting smaller, but transistors do. So transistors got really, really fast. We reorganized computers around having much more transistor density, so you can have more flops. But now you went from a world where you had 1-to-1 massive memory to a world where you have 2.5 orders of magnitude more flops per byte moved in order to saturate the compute. Right? So that's the entire game, is rewriting computation from the point of view of the hardware so you can make that workload run faster and more efficiently. And that requires understanding a lot of stuff. Right? And that's where the challenge is. It's really low-level, systems-level optimization.
What would you say, maybe that I can take as homework, are the kind of canonical examples of really great work in this space that I could, stand to learn a lot from? Like flash attention, kind of comes to mind. What would be the top few for self-study?
Oh, man, there's so many. Honestly, if you want to study kernel programming, want to get a really book, one of my colleagues, I think, has the defining book on this, the CUDA handbook. Right? Yeah, it was written by Nicholas Wildt. He's one of the fathers of CUDA. Right? He's broken this down into one of the simplest ways of understanding it and getting a full breadth and depth view of how the hardware works, how does it want to be programmed, what is the right programming model and execution model, right? And ultimately, it's usually a lot of clever insights to make a problem. You have to change the problem and create a new problem to make it easier for the hardware in a lot of ways. That's kind of what flash attention did. It was a set of novel insights that were built off of other insights. Right? So it wasn't just one thing. Right? But that's definitely one good example.
Let me see if I understand this correctly. So Tachyon is a compiler, and the compiler sits on top of the kernel, basically. So basically, you're writing kernel level instructions using the compiler. Is that correct?
So kind of. Well, I'll get into it in a sec, right? So when you think about hardware, right, the hardware has a certain execution model. That execution model is how the hardware wants to actually run this code efficiently. Your job as, when you're writing a compiler, right, you are connecting a programming model, which is the way a developer writes something in a way that they understand. And then you need to lower this down to the machine, right? So fundamentally, a compiler is a translation device.
Yes.
Right? Now, for me, I'm a Star Trek guy, so I love the concept of a universal translator, right? And that's also partly where the name Tachyon came from. And there's a whole set of jokes in there for later. For folks who haven't seen Star Trek Next Generation, they at some point come across a planet called Gotana that has a tachyon core, so things move really, really weirdly and fastly around it. And so our entire platform is going to be called Gotana, that's built off of this stack that's called Tachyon. Now, part of the reason we chose that, and it was fitting, was people think kernels are the speed of light. Right? That's sort of the canonical speed of light for a workload is the fastest kernel you can have. That is true in a compute-bound world. We are not in a compute-bound world. We are in a memory and network and communication or bandwidth-bound world. Right? So that changes things already. And the reason I say kernels are the new assembly is writing better kernels no longer gives you performance. Right? Because a better kernel actually exposes the latency of the system because now it is waiting for memory. Right? So you want to think about GPUs, for example, as 1,000 piranhas just sitting around chomping. Right? If they don't have things to chomp on, they're going to get really agitated and bored, and they're still going to be consuming energy. So you want to feed them as much as possible. Right? And that's ultimately the scheduling problem that exists here. Now, the reason I say kernels are the new assembly again is I don't think we benefit from writing them anymore. What we need is something that makes developers more productive. Right? The time to value really matters. If I can give you this experience of I'm writing in PyTorch, I say PyTorch.compile to whatever, and it gives me the same performance or better performance than what I would have gotten if I had waited 9 months with a team of experts and gotten that kernels written, wouldn't you prefer that?
Absolutely.
Right? That's what I'm trying to give. So in that world, a kernel becomes something that the compiler generates, but then people have to execute that. And that's the system we're talking about. So this compiler takes in this graph, it rewrites the workload from the point of view of the hardware by looking at the memory hierarchy, and it arranges things from the point of view of the memory hierarchy. It does partitioning, it does fusion, so it creates these work set items. Then it thinks about how do I move computation closer to where memory already is, so I have to move it less far. Because every single time you move down part of the hierarchy, your cost of data movement grows by at least half to a full order of magnitude. So if I can avoid doing that, I can create more throughput for less cost.
What are some of the metrics that you could quote? Like, does it speed up a certain the performance of a certain model by X times, or what kind of metrics do you use internally as kind of like the North Star of what you're doing?
We look at a lot, right? So for LLMs specifically, we'd be looking at time to first token, time between tokens, overall intertoken latency. We'd be looking at the prefill versus decode when you do have them disaggregated. We're looking at not just that, but pre-processing to post-processing, the entire lifetime of a request. And also we're going beyond requests because I don't think tokens are the optimization unit anymore. It is the full trajectory. Especially as you think about reasoning models and agents, that becomes much, much more important.
So what is like the time to first token improvement that you've seen upon deploy?
Yeah, so we're not in production yet.
I see.
For this kind of a stack, we care a lot about, and ultimately we are selling trust. Right? So the developer infrastructure, developer tools is ultimately about trust. You get one shot to prove yourself, and if you fail at that, you have lost it completely. And regaining that takes much, much longer. Right? So you take time to make sure you're working with your design partners and your future customers and your channel partners and making sure things are working as expected, so that once it comes into your hand, the time to wow is immediate. That is what we're optimizing for.
But so, how do you like when you tell them what could be possible? Like, what is the, I mean, what kind of, like, you know, is it going to be 20% better? Is it going to be 50% better? Is it going to be, you know, 90% better? Am I going to cut time to first token, you know, to 1/10 of what it used to be on a Llama 3, you know, Llama 32B, or, you know, one of these like reference models that we tend to use? Like, what is the cell that you know?
So we're accelerating the full workload, not just kernels. On a single kernel right now, like MapMol, on AMD 300X, we have shown that we're 1.7x faster.
Okay.
Right. So proving that we can speed up a compute-bound workload already is a huge thing. But our entire system was designed to accelerate the full workload, especially in cases where you're memory or network bound. Those cases, when you look at that and you start scaling, that's where the real problem is. Getting really, really good performance on a single device is a solved problem. Getting performance on a heterogeneous cluster, as you're thinking about larger, more dynamic models and scale, that is the real problem we're trying to go after. Right? So the time to getting up and running on a new hardware for a same workload, and time to performance, and then how reliable that is. That is what they're interested in us for. On a full workload, we can expect, say, 2 to 3x. When you're looking at a large training run, we can expect like almost 30x.
Oh, wow.
Right? There's a lot more opportunity to speed up and improve things on the larger system than there's in the smaller system.
Incredible.
Can you talk a little bit more about how you think about bottlenecks across the system? I just had a conversation with somebody from MongoDB yesterday who has given me a long history, well, a short version of a long history of database technology. And he was saying, you know, originally going back to 1970 when SQL was introduced, the constraint then was disk space, actually. And so the big reason that you have this like data normalization as kind of canon in data storage is that people were really trying to optimize for keeping the disk footprint as small as possible. When MongoDB itself was created, that constraint had basically been solved by the progress in hardware, and, you know, disk space had become cheap, but developer time was like the new constraint. Everybody wanted to, you know, get their apps out fast. Now, you know, we have the compute bound paradigm, but you're saying we have the memory is kind of the actual constraint. I'd love to dig in a little bit more there and kind of understand, like, especially in this sort of long horizon agentic world, what does that really look like when an agent makes a tool call and then there's latency? Like, what happens to the KV cache during that wait? Does it like get shuttled off and brought back and somebody else's stuff is using that same chip in the meantime? Does it have to wait? Give me a sense of like what's thrashing around there and what kinds of optimizations move the needle.
There's a saying that a prof of mine used to have is scaling what works is different from what works at scale. Right? And we're in this really interesting world right now where everything was built, all the software was built on the assumption that you're programming a homogeneous device, you're programming a single chip, the workload is static and is understandable. All of a sudden, we very quickly ran into a world where Moore's law and Dennard scaling stopped working for us. We came in with a lot more heterogeneity to, you know, come up for that, make up for it. Chips went from simple things to becoming a whole system. Like the machine went from becoming, you know, like now you have an entire cluster that is one machine that we're using to program these things. The workload is getting more dynamic. It's becoming more branchy. It doesn't fit inside of a single GPU anymore. You have to worry about newer regions. So where you place things matters a lot. And the trade-off becomes recompute versus refetch, right? And then how local can you keep things? Right? If you are local, you can, you know, reuse a lot of things and save on data access and data movement. and get more throughput. So then you have to partition that and manage a lot of overheads. That is the primary issue. Right now, for KV cache, you are trying to, and again, that also comes down to prefetch, refetch versus recompute. In some devices, like if you look at Tenstorrent, right, a Tenstorrent device or a Cerebrus device, you don't have to worry about it that much. Right? You will still get speedups. But on devices that are memory constrained, that really, really starts to matter. So it's not one answer, right? It changes based on the system. Right? And that changes your economics and what is possible. Now, for going from a model to an agent, right, a lot of things have had to happen. You went from a base model that was then, went through some fine-tuning process and got a personality. It started learning how to do certain things. You had to connect that to an environment so it can learn how to reason, and you had to learn how to use compute more effectively to solve problems. Right? Then you can think about tool calling as another add-on. Right? Having tool calling and reasoning doesn't make you an agent. It's all the things around you, being able to talk to the other world and make certain decisions. And then there's a difference between the kind of decisions you can make for different kinds of agents. All of that exacerbates every single problem in the stack, and you're always IO bound. Right? So it's not one problem. Right? It is a cluster of problems hitting you at once. Right? And being able to make the best choice at that point in time is what it comes down to. And this goes back to part of why I think the kernels need to go away, is all of that is dynamic on execution, and you don't know what needs to happen until runtime. But in the kernel world, you are pre-baking decisions before the workload executes. Right? So you need to be able to make the right decision in the most efficient manner and place things where they need to be placed based on future access. So this is why I said the workload right now is the agent. It is not an LLM with a serving engine and an agent built outside of it, where you don't have visibility across. That needs to change. And so we started from the point of view of looking at heterogeneity, what needs to change, and how workloads are going to evolve over time, what breaks when, and how do we build that kind of a system. And the big part for us is the runtime. Like that is a very big piece of the innovation we made, precisely for this reason. We essentially have this sandbox of an environment in which the code executes. And this is on and across machines. Right? That allows us to create that illusion of abstract or single unified memory for developers, even across NUMA. And we can collect those traces as we're executing, and we can continue to optimize them after the fact. Mm-hmm. Right? So if we make a poor decision around where we place something once, we can learn from it and continue to improve in the next case. Right? So your system keeps improving as you keep running more workloads. Mm-hmm. Right? And the reason I'm saying this is the right answer is going to change over time.
Is that process itself? Yeah. Oh, sorry. Well, quick follow-up. Is that process, I guess, everybody's, of course, using AI to accelerate their development, right? And when you had said a bit earlier that you want to speed up developers, part of me was thinking, well, are developers still the bottleneck that they were when MongoDB was created? Because now we've got the agents to do a lot of acceleration at the developer level. So I'm interested in your thoughts on that. But then what I'm really kind of wondering is, where is the intelligence used throughout this optimization process? Like, are you using agents in the sort of innermost loop that is looking at, oh, workload is changing right now, we better adjust our approach? Is there like a frontier LLM at that level being used to optimize the runtime decisions on an ongoing basis?
Yeah, not an LLM. There's many ways of having intelligent behavior without having LLMs. Right?
Never heard of them.
Well, have you heard of compilers? Right. So compilers have always been very entrenched with AI in a lot of ways. Like, so in this case, knowledge-based systems, right? A knowledge-based system is essentially what a compiler would be, right? Because you have certain information or knowledge about how to make things go fast that you want to codify so that you can get the result fast and just making known good choices, and you get a verifier for free because compilers have to be correct, right?
Dropped off.
Come back.
He should be back in a bit. We speak to so many. We've spoken to a couple of chip companies. We spoke to people who are managing prefill, decode, etc., and trying to rearrange that on a hardware basis. We've also seen Modular's Mojo. We've seen OpenAI's Triton GPU programming system. We've also seen Elon Musk say, "Hey, it's going to be AIs writing directly to assembly within a few years." And it's hard to think about how the software layer is going to change in the medium to long term, because it's quite clear that a lot of these compilers and stuff are going to be used primarily by AIs, right? At this point, most of the programming is already being done on the front end, by prompting, and it is hard to see where things go from there. Hi, Jay.
Okay, we're back. No idea what happened there.
So one of the questions I had, and I was just describing this, was you have Modular's Mojo, you have OpenAI's Triton system for GPU programming. Modular is, for example, trying to reduce this kind of two-language tax that you've always faced. How do all of these pieces fit together? Because is a developer now going to have to, is it another language or tool in the stack that they have to learn how to use? Is there a kind of tax that comes with having to add that piece to the stack? And how does Tachyon actually do this? Because we've spoken to some chip developers, for example, who move the data much closer to where the compute is. We've spoken to people who are doing compute inside memory. We've also spoken to one team that is doing chips that allow compute to be done inside memory. How exactly does Tachyon do this, and how does that fit into an entire stack that already exists?
Yeah, so first, you think about companies like Modular, right? What they're trying to do is build a systems-level metaprogramming language, right? So you can write kernels better. To me, it was the most literal interpretation of, I need a CUDA alternative. Let's build a language.
Mm-hmm.
But the problem is, I still have to write kernels. Right? That is on the developers to go and do. If you actually do the math for the amount of hardware that is in the world today, all the different workloads that we're running, the different numerical cells, the different fusions, the different ways of partitioning them, right? And you think about different batch sizes, you think about latency versus throughput or general input, other SLOs. You actually sit down and do that, and you're like, okay, I need to write about 106 billion kernels in order to get coverage. Well, there's only about 2,000 odd performance engineers in the world that actually know how to write good kernels. 90% of them are inside of one vendor ecosystem. So there's still a problem of, I need coverage. The reason you can accelerate some of this on NVIDIA is because NVIDIA spent 20 years building an ecosystem of tools to make your life easier so you could get the feedback. Mm-hmm. That feedback loop, right? That ecosystem makes kernel generation easier.
Mm-hmm.
Right? That maturity doesn't exist in any other vendor.
Mm-hmm. Mm-hmm.
Right? So for us, what we're looking at is, and then also, there are certain hardware that are in use today for which you cannot write a kernel.
Mm-hmm.
For data flow architectures, you have to execute a task. And that is a different granularity than a kernel. Right? The tile programming model is still within the kernels, but it's easier and more accessible for developers and raises that abstraction. Right? The reason OpenAI invested in Triton was to raise the bar, like raise the number of people that could write kernels without needing to know CUDA or low-level programming.
So if I hear you right, Tachyon is a tool that for non-NVIDIA chips is going to be very useful because they do not have that toolkit that already exists in the NVIDIA ecosystem.
Yes, we allow more non-NVIDIA hardware to become more accessible. So you as a developer can choose the best hardware based on the shape of your workload and the economics you care about, right? And you can make that choice immediately without having to go and rewrite everything. But on the NVIDIA hardware as well, we can give you more gains on a larger system. Right?
And can you describe again? So you have this thing I think called operator fusion that you're using. Like how exactly does this work?
Yeah. So if you think about like normally when you're running some kernel or some operator, right, you are reading memory, right? In GPU land, they use DRAM as main memory. So you're reading something all the way from there, bringing it into a local register. You're operating on it. You're writing back to main memory, reading it back, and then doing the computation. Well, in that time, your compute unit was waiting while you were moving data around.
Right.
And that's very, very expensive. So fusion is basically, let's not send the data all the way back. Let's keep it local and just reuse it for the next operator. Right? So it's about synchronization and barriers and so on and so forth. Like mitigate data movement. That's the name of the game. Like minimize waste. Right? And that gives you speed ups. Right? So it's sort of like if I am at my desk right now, I need certain information. It's already somewhere on my desk. Right? I know exactly where it is. I can read it. I can use it. I know I have the information somewhere. It's probably in one of the books in my shelf. I can go over to my shelf and I can grab a book. Right? That's me going from a local register to like an L1. If it's not there, then I have to go to the library next door. Right? And I was like, okay, or go to a friend or somebody else in the office. I have to travel a little bit further to get that information. But I have a larger collection of things I need to search through to find that information. Now, if you go from there to a library that's far, and they don't have that book, and then they have to get it from somewhere else, and then they have to give it to me, right? That's sort of the logical hierarchy of memory. That's the cost, right? So if I don't have to go that distance to get something, and it's available for me already, right, I am much faster and I'm better. I'm much more efficient for that, right? That's what operator fusion does.
Indeed.
Can you tell us a little bit about who faces this challenge of heterogeneous clusters? And is it a problem that people try to tackle more in inference? I assume so, relative to training. But like, how big are the customers typically, or does this or how far into the long tail does it go?
Yeah.
And then how do the other chip manufacturers respond to you and support you? It strikes me listening to all this that there should be like a consortium of non-NVIDIA chip makers putting forward like $1 billion prize for whoever can do this. But I'm guessing you had to like raise funding without that carrot out there.
For us, it was we wanted funding specifically so that we were vendor neutral. Like we wanted that to be a very explicit goal. At the moment, we are taking money from one vendor. We are more aligned with that vendor, and that skews a lot of what we prioritize. And for us, it's really important to be building for the builders. What do they need? Right? Our customer ultimately dictates. And when we spoke to them, they wanted to have more. They obviously love NVIDIA. I love NVIDIA. I want to be able to use AMD GPUs. I want to be able to use TPUs. I want to be able to use a Trainium. I want to use Tenstor and Cerebrus or Samba Nova or D-Matrix or Grok or any other chip, because each of them is better for a specific thing. Right? But if I am locked to just one thing, right, I am getting suboptimal use for a workload. Right? And we've been through this before, where a lot of good ideas died because they didn't suit the hardware. Right? If there's more hardware available and they're good at different things, more ideas become accessible. Right? We're now in the realm of talking about reasoning models and world models and planning and robotics is making a comeback. Robotics is all heterogeneous. They're full SoC with a lot of different parts. Like you look at the Jetson, like for example, it's got the CUDA cores, it's got a CPU, it's got DLAs, it's got a vision processor, it's got other DSPs on it. Right? You have to be able to access all of them. Right? The Qualcomm RB5 and RB6, similar. Right? We started originally as one of those companies building this heterogeneous SoC for robotics. So we had to deal with it. All GPUs today are heterogeneous. Right? The moment we crossed the 5 nanometer threshold, right, we had to think about complex packages. Like we are programming, and every single machine today is a CPU, some network, a GPU. You have different kinds of memory. You can have LPDDR, GDDR, HBM. You can think, and they all change the execution model. You have different numerics. Right? On NVIDIA, you have the CUDA cores or CUs, and then you have tensor cores as well. They need to be spoken differently. You have different memory hierarchies now with the core memory for the SMs, and then you also have tensor memory accelerators. Heterogeneity is already here. Everyone who is dealing with the GPU is already dealing with it. Anyone who's training a model or deploying a model is dealing with it. Right? But the software was not built for this. Right? The software is still living in the 60s. Right? We're still programming as if we've got a single core CPU, right? And GPUs are these sidecars that we throw work off to every now and then. And we can just add in libraries or other intrinsics or pragmas and just fix the problem. That isn't the case anymore. GPUs need to be, and accelerators need to be first-class citizens, and CPUs need to be backstops, right? And that changes things. And now you're programming a cluster as a single machine, right? And some of my friends at labs right now are training models across data centers. It's not even across nodes anymore. It's not even racks. We're talking about multi-gigawatt data centers or multi-megawatt data centers as one machine for one model.
So give us an idea of your kind of product rollout timeline. I think there was a beta testing that was about to start, or there's like a product rollout early next year. Like, what does your timeline look like? What are the milestones to that timeline? And how do you what's your acceleration strategy at this point?
We'll be up and running on NVIDIA and AMD hardware for the majority of models that customers care about with state-of-the-art performance at the end of this year. That's going straight into the hands of our beta customers and our design partners, and then we'll do GA in Q2 next year.
And are your buyers like hyperscalers or startups? Like,
we're a bit more focused on managed inference serving to start with. Right? And so that much more appeals to certain enterprises or AI native companies or startups that are trying to build products around the models.
I see.
From there, we will expand into things like post-training, building out for reasoning environments, building out for agents, and then adding in support for training.
So you're looking at startups that want an inference edge or saving. Yeah. Is that the focus?
Yeah. Right. It's generally people who want more control.
Is that helpful for a lot of the neoclouds are now doing bare metal? So is that helpful that you have these neoclouds offering bare metal and that customers can bring their own?
Yeah, I mean the neoclouds have always been in the bare metal business, right? It was sell hardware without all the craft. Yeah. Because all the hyperscalers had a lot of extra software and things that they were trying to upsell, right? And if people just want the fastest hardware, the lowest abstraction, that's what the neoclouds were built originally for. And that definitely works better for us in the way our stack is built. And that's who we are generally partnering with. Like our go-to-market is with all the neoclouds. Mm-hmm. And we are very, very tightly coupled with a lot of them.
Right.
Two final questions for me. One quick one and one kind of zoomed out, hopefully fun one. The quick one is just, how do you price this? Everybody's kind of trying to figure out the future model. Is it by seat? Is it by company-wide license? Is there a usage component?
Yeah. So I think, in a perfect world, outcome-based pricing makes a lot of sense, especially as you go for agents, right? But if you're a infrastructure provider the only business model that has worked and continues to work and scales is consumption-based. So for us, I mean, I know a lot of people like the token pricing right now, but tokens work really well for, you know, the static request response kind of workload, right, which is what the old base models were with the tuning. But now that you have reasoning models, it's harder to reason about token consumption, and then same with agents. There's a lot of things change. So what we're actually moving towards is effective compute consumption, right? The amount of compute you use to realize useful work, right? And that's different from saying a GPU hour or a GPU slice, right? And the biggest thing, like actually part of the reason this makes sense is our business model scales with the delta between effective compute and effective, like physical compute and effective compute. And what I mean by that is, what we're showing is the fastest new addition of compute will be through software. And it'll come online faster than you can actually plug in new hardware, right? Because you are going to be electricity bound, right? Getting turbines and power installed in places so you can bring up new silicon is the big limiter right now. If I can boost your utilization by 3 to 10x, I'm adding in new, more effective compute at a lower cost that I can sell, right? And the consumption of that resulting into tokens is what we are reselling, right? And that scales really nicely. And it's something that's understandable for a lot of the finance people as well, right? Because for a lot of them, the token pricing and other pricings are breaking right now.
Interesting. Thank you. Okay, here's the fun one. You mentioned you're a Star Trek fan, and the website certainly reflects the futurist aesthetic. What's your positive vision for the future of humanity as we go into the AI era?
Like, I am definitely a believer in a human first kind of outcome, right? I think AI is a new kind of intelligence. It's different from human intelligence. It can be complementary, and what it's showing us is there's a lot of work that we have been doing and describing as work that maybe wasn't actually work and we should never have been doing in the first place, that we can start offloading. And that allows us to have more leverage to do work that we are uniquely suited for. It, to me, creates much more equity. So we can actually try out new things. We can accelerate discovery. We can learn more about ourselves and the world. And that results in more solutions or more problems being solved at a lower cost than they have been before. There's been, like, personally, I'm really interested in what happens in drug discovery and design. There's been so many places where pharma hasn't been able to get to because the cost of research was so high or there wasn't enough of a data set. If, like, biology you start going from squishy things to bits, things get on an acceleration curve and you can get a lot more benefits out of it, right? The quality of education has been fairly crappy, right? And it hasn't kept up with the pace of the world. And I think, yeah, I can help push that gap. Right? There's a lot more that can happen, right? And you think about, I think deep tech is going to be way more important going forward in the future. And simulation is going to unlock a lot of it. And AI plays a big role in that. We can expand the tech tree. We took a very particular branch and we've just been going off of it, right? And there's been all these inherited biases that have guided us. If we can unroll that and we can expand more, who knows what's possible? And I'm personally excited about that.
Love it. Me too. Also a tiny bit afraid, but very much excited. Jay Dawani, the company is Lemurian Labs. The stack is Tachyon, and there's a lot more to come. So we'll be watching, as always, for your updates.
Thanks so much. Thanks for having me.
Cheers, Jay.
Great to meet you.
Bye.
Amazing.
Yeah, which way does this all? I mean, it seems. I guess if I had one more question, I might have just asked him, like, what's going to happen to the per hour rental price on chips? You know, can these sort of utilization improving layers do enough to keep those costs stable, or are they going to continue to run up? It seems like the smart money is still on. They're going to continue to run up for the foreseeable future, but. That's really, I mean, it is amazing how much the sort of, performance held constant pricing has come down. And, if they're successful, there'll be another chapter in the, long and ongoing unfolding story of ways to bring the same intelligence to people for dramatically less. And yet it still seems like the paradox is in full effect, right? We are definitely buying more and more and more, and so much so that the per chip price is going up, even as the efficiency with which the intelligence can be delivered has dropped so dramatically. It's really quite something. The era's come at us so fast in this space. The moment we had, I forget exactly when it was, but there was a moment where it was like, oh, there's a GPU glut. Wow, those days are long gone. Just to think about it, another kind of interesting reflection on all this is just like all that complexity is the kind of thing that people are willing to take on because the chips are just so scarce. It's wild to think about. He's in a way, he's sort of solving the, trying to get developers to be more productive, faster to ship stuff. But the other way that would be like faster to ship stuff is not to have a heterogeneous cluster and, just to pay up a little bit more on the hardware side to keep it simple there. But you can't. It's just too expensive, so you have to take on the complexity on the developer side, and then you have to have attempts to solve that complexity with projects like this.
It strikes me that, I think for people who are not deep in the weeds, they don't understand, I think, the margin stack that exists, because the hyperscalers charge, I think, about 30%. The gross margin is about 30 to 40%. NVIDIA is up there at like 70%. The memory guys are at like 80 to 90% now. And all of this stuff like stacks on top of each other, right? And when you look at how they end up stacking, and you have at the very top OpenAI with or Anthropic with a 70 to 80% margin, and they're buying tokens from Amazon with a 30% margin. Amazon's buying chips from chips and other things from other people, and those people have like 50 to 60, 70% margins. Everyone then manufactures at TSMC, and they have 50% margins. And TSMC suppliers, ASML, they have 50% margins. And when you look at the margin stack, right, like this $50 billion, per gigawatt data center, it's really kind of made out of sand, literally, in some sense, made out of sand. Sand and intellectual property. And when I think of it, it's all of that money is just the incentives required to get the humans, some of the smartest humans in the world, to take a look at these problems and fix them, right? Like all of that money, like because again, the physical elements inside that data center are actually worth not that much. Very little gold in there, very little gold, and mostly silicon, some plastic. And if you just knock down the entire data center and kind of sold it for scrap, it would be literally worth like cents on the dollar, like few cents. And it just strikes me how much all of it is just intellectual property. It's really just know-how, intellectual property. It also somehow strikes me how AI data centers are kind of this like, crowning achievement of humanity as a whole, in the sense that how many of these parts come from, you have like, argon gas from Ukraine, and you have like copper from copper mines in Mongolia, and then and all the way up the stack, you have like chips from China, rare earth metals from China, chips from Taiwan. You have energy being produced in Texas, and all of that just stacking up and pulling. And I often imagine it as like this entire thing pulling the rest of the economy up, because it's creating demand across all of these different segments. of the economy. And it's all rather invisible, I guess, because it's kind of distributed across so many different places. But yeah, just this immense economic endeavor of humanity as a whole in order to build these things, and it's just amazing. It's really amazing, like what the invisible hand has achieved over centuries. So
this is why the rationalists at their solstice festivals have experimented with singing hymns to the global market and global supply chains.
Have they? Do they really do that?
I wasn't in attendance for that, but yes, I do know on pretty good authority that winter solstice, rationalist event did at one point feature a hymn to the global supply chain. Now with Suno, you could probably make it a banger. I suspect, or certainly the suspicion broadly. I won't prejudge it, but I think the suspicion broadly would be that would come off pretty cringe. But maybe it's just a matter of needing better bars to really make it work. And if my recent experience on Suno is any indication, maybe we'll see what we can do in terms of a hymn to the global supply chain. See if we can put our money where our mouth is and have one that we'd actually enjoy singing along to.
The rationalists are never going to get out of the accusations of being a cult. I tell you, like the moment they step out, they get pulled back in.
Well, they might just be proven right in the long time scale of history, though. Would it be so surprising if, at some point in the somewhat distant future, there was a hymn to the emergent order of global supply chains that somehow materialized before we even had machine intelligence to run it? I think it's not the craziest idea I've heard.
I definitely have rationalist sympathies. So as I point out often, like it is I do hold a lot of the same viewpoints, if not, but I do not come to some of the same conclusions that they do. But yeah, it is. In fact, I also think Trump, to a large extent, he is leaning on the strength of the global supply chain in some sense for this Iran war, for example, and he's definitely leaning on both the strength of the global supply chain and the strength of, I think, the global financial markets to a large extent, to when he makes trouble and he wants to fix these long-running problems that the U.S. has had, and he goes in there like a bull in a china shop and he does these things. He leans on the fact that I think the rest of the system is very resilient. And I think COVID kind of showed that kind of resilience. And COVID, I also believe, made the entire economy more resilient, because now everyone knows that they can work from home. So no snow day will ever stop business. We all know that it's never going to stop business, right? So it's also proven out the entire DARPA thesis behind the creation of the internet, because hey, it's very clear now that you cannot, a nuke is not going to take out business from running. It's just business will just go on. So you cannot just bring the country to a stop that easily. So the hymn to the global supply chain is maybe well deserved.
I'll get Claude on some lyrics immediately after the show today.
Just to maybe round out the show with something that we started out on, and so I feel like I have to round out the show with the same kind of thing. For Pew Research Center, for the first time, a majority of adults under 30 say they're more concerned than excited about AI. Their concern is now on par with those in their 30s and 40s and those 65 and up. And so we have the only group still under is the 50 to 64 group. So the Gen Xers are still, majority are still more excited than concerned. Everyone else is now in the more concerned category. I kind of don't know what they're concerned about, because I would be a lot more concerned about Instagram than AI. But I feel like all of the evils that were said about social are just being heaped on AI with no kind of defense or recourse. So.
I just hope we don't get the nuclear outcome. When I read these things and all this data center backlash stuff, and the Republicans saying, we're the only ones that will, that you even have any chance of getting to support this kind of activity. It really makes me fear that we might be headed for a world where we get all the downsides and not nearly as much of the upside as we should. With nuclear technology, we've got still 10,000 nuclear weapons globally deployed, which is, I think, by any rational account, like an insane number. And we do have some nuclear energy, but not nearly as much as we really should. I think that's pretty obvious at this point, although it's obviously still contested, but it's pretty obvious to me. And I would just hate to see a populist backlash leave us in the same spot with AI, where we get like militarization and concentration of power, and you can't release models because there's not enough, potentially for multiple reasons. But one, increasing reason would be if they can't build the data centers, there's not going to be enough compute to serve them. And so retail, is going to get kind of a less than model compared to what the government itself or the biggest enterprises can afford. And I am very sympathetic to all those worries. So as much as I do have fear of big picture AI gone wrong, I think there's like enough data centers already for those experiments to continue. And I think we need to address that at a different layer than the physical build out. The physical build out, I think, is what's going to allow us to all get the day-to-day benefits that we want as individuals, with unlimited access to expertise and, unlimited, digital personal assistant support, and even that robot, making our meals in our kitchens and sweeping our floors. Like, that future really does seem to depend on the build out actually happening. So I hope they figure it out, man. I hope they start to cut some checks, and pay off the public. If not the, I wouldn't advocate for paying off the officials, but I would advocate for paying off the public, if that's what it takes to get us over the hump and get people a little more comfortable with this kind of stuff, because I really don't like the alternative very much at all.
I think it's pretty clear at this point that physical construction in the US is very difficult. And I think it's difficult regardless, because data centers are the cleanest industrial facilities you will ever find in the entire world, right? And they're able to pay for fuel cells, which basically turn natural gas into water. And they're able to pay for that, and they're able to pay for solar energy. They're able to pay for solar and batteries. And regardless of all of that, and they don't employ a lot of people, so there's not a lot of traffic either, right? Like a typical 50 gigawatt data center employs about 200 people. So there's not a lot of traffic issues, and there's not a lot of creation of new housing, et cetera. So given that the impact of the impact is not that great in terms of like physical, the fact that you are seeing these bodes very ill for future reindustrialization of the US. And I think it's very clear now that there's going to be a huge resistance to moving Chinese factories back to the US. I think it's going to be very untenable to think about robotic factories, dark factories producing large robotic dark factories. So I think that's clear. It also gives a boost to Elon, because Elon is focused on moving the data centers to space. So And I think on the numbers that he has, I think they are looking at like $100 an hour per GPU hour for a B200 for it to make sense. And if you look at where GPU hours are being priced at right now, they're at like $2 to $3 on a spot and 20 to 30 bucks on a longer term basis. It tells you that what we're going to see is we're going to see all of this resistance that pushes up the price of GPU hours onshore to $50, $60, $70, $80. And so I think the numbers that you end up looking at is that, are the data centers willing to pay maybe 100% of their GPU costs to the public, or 200%, right? If you're renting at 30, are you willing to pay another $60 an hour to the public? And remember, the payback time of these is something like 12 to 24 months. So they're looking at like a $50 billion GPU cluster makes about $30 billion of revenue a year, and about 70% gross margin, 21 billion. Are you willing to pay like $10 billion or half your margin away to the public? I don't think those numbers have been met yet. I think people are like looking at like cents on the dollar at this point. And the question is, how high does that have to go in order to make this more feasible to build onshore than in data centers in space? And I think those numbers are, I think no one wants to discuss, I think we're going to have to pay $20 an hour to the public as a nuisance fee. I think those numbers are still not being discussed yet. And I think that's where, these guys are thinking like, I can pay, 10 cents for GPU hour or 5 cents for GPU hour and get by. So.
Well, maybe this is the path to universal basic income. I mean, it's going to be a really weird one if it's like a county by county patchwork. But, you're talking real money there with that kind of share, if it can get to that level. And, there's some room between, operational costs and what it would cost to do it in space. So, maybe that gap is the UBI opportunity.
That county that you mentioned earlier with 29,000 people, they would be getting something like $500,000 a year per person. So at those numbers, yeah, I think deals could be made, right? Like people will be like, all right, I'm going to have my location here. I'm going to take this $500,000. I'm going to move to California, or I'm going to move. Like everything becomes, everything becomes different, right? Like the whole ball game changes once you go from like $2,000 a year to $200,000 a year. Right? It's a different ball game. So.
Yeah, as my dad sometimes likes to say, it's not the money, it's the amount.
Uh-huh. I have much saltier ways of saying that, but I won't.
Yeah, everybody has a price, including the public.
Yeah, indeed. Very good.
Well, we're off tomorrow, as Sam Altman prophesied. People will continue to swim in lakes. It's going to be lake day for me tomorrow. And then we'll be back on Monday for more exciting experimental public sense making here on AI in the AM.
Indeed. See you guys on Monday next week. Cheers.
Thanks, Prakash. Bye.